So something like this. You are asked to find the equation of the tangent line to some function, and then they're going to give you a point. So this always kind of starts out like that. They say, I want an equation of a tangent line to a function at a point. Okay, equation of a tangent line to a function at a point. So usually what happens is you look at that question and you say, oh, what kind of line? When it says tangent line, it means it wants a derivative, or basically it's a line that goes through only one point, then that has to be a derivative. So first thing we need to do is find the derivative of this function. Okay, and at this time, you need to always use the definition of derivative. Definition derivative means you have to start with your limit notation. Limit as h goes to 0 of f of x plus h minus f of x over h. So this definitely will be on the quiz on Friday. You do need to start from the definition of derivative, which is this limit notation, to find the derivative. The function is square root x minus 2. So go ahead and find the derivative using the definition of derivative. All right, so if you find the derivative, which we would write this as f prime of x, it's going to be 1 over 2 root x. Now, we want to figure out the slope at this point, which is 4, 0. That means we want to find the slope at 4. So we plug 4 in there, so we get 1/4. So 1/4 is the slope at the point 4, 0. Now, they're asking for a tangent line, which means they want an equation to the line. Equation to a line means you need two things. First thing, you need the slope. Second thing, you need a point. So those two things will always create a straight line, a linear line. So you already found the slope. The slope is f prime of 4. The point is 4, 0, which they gave you. So what you're going to do, this is what you're going to do for now on with writing an equation of a line. You're always going to use point-slope form, not slope-intercept form, because both forms are acceptable on the AP test, but point-slope form is faster because you don't have to solve for the intercept. So from this point on, you write it in this form and do not simplify. Okay, so you're plugging in 0 in here, and then the slope is 1/4. And that 0 is negligible, but if the y value were not 0, you just leave it like that and without simplifying it, and you get full credit. So you want to leave everything in point-slope form, no more slope-intercept. The reason being, you take the least amount of work to do your test or work, because this is acceptable, and if you do further work, you might take the risk of making a calculation error and then lose points. Okay, so if you leave it like that, it's perfect and you get full credit. All right, so let's try another one. This one is kind of asking the question in a backwards way. So the first question was like, I give you a function, I give you a point, find a tangent line. So it's kind of straightforward. Now they're going to kind of ask you backwards and see if you do understand what you're doing. It says the tangent line to the graph y equals h of x at the point -1,4 passes through the point 3, 6. Okay, find h of -1 and find h prime of -1. All right, that sounds very confusing. So the first thing you want to do is try to make sense of the problem. Maybe you can try to draw h of x. Okay, it really doesn't matter how this looks like. It says that there is a tangent line to this graph. And that tangent line is at -1,4. -1,4. So maybe here. So there is a tangent line. So they're telling you there is a tangent line to here at -1,4. Now it tells you the next thing. This line passes through 3, 6. This line passes through 3, 6. So something like that. This is 4 and -1. So first thing is you have this function h, and then they tell you there's a tangent line. that tangent line hits that graph at -1, 4. When you create this tangent line passes through another point. That point is called 3, 6. The question is, what is h of -1? Meaning, if you put -1 in this function, what is the y value? Can you think about it? Raise your hand if you have an idea. Yes?
4?
Yes. Because it tells you this point is on the function, therefore that number must be 4. So that one was just kind of not a tricky question, but just like, do you understand what you're doing? Okay, the next question is h prime of -1. Raise your hand if you have an idea. What are they asking for? H prime of -1. Raise your hand. Yes. The derivative. Correct. What does the derivative mean? Raise your hand if you have. Yes.
Slope.
Yes. They're asking for the slope at -1. How are you going to find the slope at -1? Yes. Yes, use those 2 points. You know this point, you know this point. They're just asking you for the slope of that line. Okay, so once you kind of decipher everything, you'll realize this question is very easy. So now all you have to do is find the slope at -1, meaning the slope of the tangent line. Okay, so go ahead and figure that out. Hey, raise your hand if you have the answer. What is the slope at -1? Yes, Elizabeth.
Oh, 1/2.
Yes. So when you look at this question, it might look difficult. Just kind of think through everything. Slope means derivative. I have a tangent. Tangent means derivative. So all those things are related for you to figure out what they are asking you for. Next. Okay, there are a lot of things that mean derivative when you see something prime. So something with a prime, whether it's f prime or g prime or something like that, anything with a prime, it always means derivative. Another way they're going to say derivative is they're going to write something y, something x, and d means derivative. So basically the derivative of y with respect to x. So meaning I am taking the derivative of this function y, or whatever function they give you, with respect to means that is the variable I am differentiating with. Because sometimes there might be more than one variable in that equation. It could be an x, y, and z at the same time. But we're only going to take derivative with only counting one of them as variable. The other ones we just say don't care at that time. So the question is with respect to what? Which one is my variable? That is the question. Okay, so when it says x, that means x is the only variable, everything else is a constant. We don't care. Okay, if you have questions, write it down. You can ask me later. So same thing with this one. You know, sometimes you're going to see f as the function instead of y, and then it's always going to have a denominator telling you, oh, which one is the variable, which one is not variable. Another way you will see it is something like that. It's kind of the same idea where you put the function on the side. Okay, so just showing you different things so that when you see it, you're like, oh, derivative. Those are the main ones of how you're going to see derivative. Basically, if you see a d with dx, that usually means derivative. Okay, so let's try these. Okay, so let's go ahead and draw this graph out, whatever function I give you, draw this graph out, and then we're going to try to find the derivative without doing a lot of work. Okay, f of x equals 5. Can someone tell me, raise your hand and you can tell me what that looks like? Yes?
Straight line at 5?
Yes, straight line at 5. Therefore, raise your hand if you can tell me what is the derivative. Yes? 0. Yes. Why is the derivative 0? Someone raise your hand if you can tell me. Yes?
Because it's a straight line.
Because it's a straight line, so?
So there's no...
Yes?
The slope is 0.
Yes, the slope is 0. Yeah, so you want to say the slope is 0, meaning the derivative is 0.
The derivative is the slope.
There is no slope. It's 0. It's a flat line.
Is there even a derivative?
Raise your hand if you have a... write it down first.
Is there a derivative?
The derivative is 0.
How? But it touches every point.
So this tangent line is going to be, the tangent line is going to be flat, touching every single point on that line. So that tangent line is a flat line, which means the slope is 0. What are your questions on the post-it, please? Okay, next question. F of x equals x. Raise your hand if you can tell me how this looks like. Yes, Ben.
It's a diagonal line.
Diagonal line this way, yes. Can someone raise your hand and tell me what is the derivative? Someone else. Peter.
1.
Huh?
1.
1, yes. So, can someone tell me why it's 1? Raise your hand. Someone else. Okay, George. The slope is 1. Correct. Okay, next one. This one is a little bit tricky. Okay, absolute value x. What is the derivative? Raymond? Plus minus 1. Very close, very close. Yes. At some point, because you guys did write the correct answers on the WSQs. I saw that. Yes. Non-differentiable at 0, correct, but what about other places that's not 0? Yes. Yes. So you can see that this function is basically splitting up into 2 different parts, right? 2 different shapes or different slopes. So basically, we have different derivative at different points. At -1, x less than 0, it's going to look like a -1 because that slope is -1. When x is greater than 0, it's going to look like 1. And like you guys said from last night's video, at 0, it's not defined. Therefore, when we write this, we don't include 0 because it's not differentiable. So we're going to go into differentiability, but before then, I am going to check your how much you remember about IROC versus AROC. Okay, so I'm going to just go down vocab by vocab. You guys can tell me all together if it's IROC or AROC. First one, slope of the tangent line. IROC. Tangent means at only one point, so that is instantaneous. Okay, next, difference. I didn't tell you difference quotient. Okay, difference quotient is this thing. Okay, so difference quotient. I am so bad at this. I'm sorry. Let's come back to difference quotient later. Okay, this one. AROC. Okay, let's skip that for now. Instantaneous. Oh, that's already IROC there. Slope of the secant line. Good. Derivative. IROC. Okay, average rate of change is already there. This one? Good. All right, difference quotient. Difference quotient means this one, meaning it's the difference quotient. Difference meaning subtract, and quotient means divide. So it's the difference quotient. So this first one is an AROC, and then if we take it to the limit, that's going to be IROC. Okay, so just double checking your vocab here. All right, differentiability. All right, differentiability is a confusing concept. So on your WSQ, go ahead. Yeah. On the WSQ, most of you guys, I would say 70% of you answered correctly. 30% of you, unfortunately, answered incorrectly. So the question was, if the function is continuous, does that mean it has a derivative? No, it doesn't. A lot of you said something like this. Yes, a absolute value graph is not differentiable at this point, even though it is continuous. Therefore, something is continuous does not automatically mean it will be differentiable. Okay, so differentiability means what? Differentiability means the derivative or we call that the difference quotient exists at the given point. So simply, differentiability just means that there is a derivative at that point. Someone asks you, is it differentiable at x equals 2? You're just saying, is there a derivative at 2? If someone says, is this function differentiable? They're saying, does every point have a derivative? That's exactly what it means. How are you going to check if it's going to be differentiable? First, anything that is not continuous will definitely not have a derivative. Okay, so if it's a whole, if it's jump, if it's infinite, no derivative. If it's not continuous, no derivative. Okay? So you want to ask yourself, is the function continuous? Continuous at that point. If it's not continuous, definitely no derivative, no questions asked. It's not possible. Next, if it is continuous, then it becomes a little bit tricky. You're basically asking, is the left-hand side derivative and right-hand side derivative the same number? Is the left-hand side derivative and right-hand side derivative the same number? For example, this one, this is continuous, so then the question is there a derivative at this point? So you find the slope on the left, the slope on the right, and you say, are they the same? Okay, this one is not the same, therefore not differentiable. So let's write that down. So is the left-hand side derivative? That means the limit as h goes to 0 from the negative side of the difference quotient. Is it equal to the difference quotient or the derivative from the right-hand side? So it's basically saying, is the derivative on the left and right the same value? Okay, let me go through 2 examples and I'm going to open up 2 questions. Okay, so again, 2 things to check to see if it's differentiable. Number 1, is it continuous? If it's not continuous, no derivative, for sure. Number 2, if it's continuous, then is the left-hand side and the right-hand side derivative the same? If it is the same, then it is differentiable. Okay. So determine the continuity and differentiability at a given point. Because continuity and differentiability are different. Continuous and does not mean differentiable. So we have this function, f of x equals absolute value x, and they want us to figure out, is it continuous at 0? Is it differentiable at 0? And if it's not continuous or not differentiable, why? All right, so first, raise your hand if you can tell me, is it continuous at 0? Okay, yes. Is it differentiable at 0? No. Why not? Yes.
Because the 2 slopes on the sides are not even.
Yes. So let's say f prime from the left of 0 is -1, and then f prime on the right-hand side of 0 is a +1. So they're not the same, therefore not differentiable. Let's look at the next one. This really strange function. All right. Raise your hand if you can tell me. Is it continuous at 0, William? Yes. Is it differentiable at 0, Elizabeth?
No.
No, why not?
Because the slopes are different from both sides.
Yes. So then we can say that from the left-hand side, it's a negative. I don't know what that number is, but it's negative slope. And then on the right-hand side, from the right-hand side, I mean, it is a positive slope. All right, let's open up for questions. Any questions? Yes?
Do you
Yes.
over dx.
Yes.
What you said completely wrong.
Okay. All right. For example, so in the future, like right now, you're not really going to see anything. All your equations are going to look something like this. X squared plus 2x plus 1, something like that. It's a f of x, meaning the only variable in there is x. So when you're taking derivative, you're basically saying x is my only variable. But in the future, you're going to see something like this. Well, maybe something like f of t. Then you're going to have maybe like 2xt. Then you have two possible variables in there, right? X and t. So the question is, which one's a variable, which one is not?
Oh, so which one you're plugging in x plus h into?
Right. Which one do you consider as a variable? Which one do you just ignore at that time? Now, if you say df dt, then t is the variable. If you say df dx, then x is the variable. And you ignore the other one. Like you would just think the other one is just constant. Constant meaning like it's just like 1, 2, 3. Because at that time, you don't care. Okay, Taya.
So anything with the unit is just asking for the derivative.
Yes. 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 Question. No. We'll look at some of them. Yes. Depending on what point. Yeah, we'll look at that together too. Yes.
Okay, can you plug it in so I can like see it?
Okay, so like for example, if you are doing this one, you would do it's 2 dt. Okay, so then 2x, and then that's going to be t plus h and so on.
Got it.
Yeah, basically you're saying t is my variable and not the other one.
Got it, okay.
Any other questions before we go on? Yes.
So for x squared, there wouldn't be any differentiability.
Yeah, so that was Sophie's question. So we'll kind of talk about that. Yes.
Can you go back to the two graphs?
Yes.
How do you, so which line's slope are you looking at for the second one? Because you're looking at the tangent line, right? Can you draw the tangent line?
Yeah, that's a question. So I think the next one we're gonna try to draw some of these. But yes, I can help you draw the derivative. So actually, that's a great idea. Let's look at it and figure out how the derivative graph will look like, which is going to be the warm-up tomorrow. Okay, so let's look at this. Any more questions before we go on? Okay, so let's look at this. Let's say this is my f of x, and let's say that we now want to draw our f prime of x. We can draw the derivative graph. We just need to figure out what is the slope at every single point. All right, so let's take a look. At x equals 1, what is the slope of the line? Everybody? 1. At 2, what is the slope of the line?
1.
So therefore, when you're drawing the derivative graph, at 1, the derivative is 1. Okay, so you put a point there. At 2, the derivative is 1. So basically, it's going to be like that. And it's going to forever be 1. And you're going to get really, really, really close to 0. Let's say you're at 0.1, which is like really close to 0. What is the slope over there? 1. So let's say this is 0.1. You're still at 1. But what happens at 0? Nothing. Like basically, there is no derivative, right? So in this case, since we are just trying to get really close to 0, that is actually going to be a hole because it doesn't exist there. Okay, now nothing happens at this point. Let's look at the left-hand side. When you're at -1, what is the slope of this line? -1. When you're at -2, what's the slope of this line? -1. And then when you're really close to 0, let's say -0.1, what's the slope of that line? -1. So you can see that this is also going to have this kind of behavior. And when you're almost at 0, there is nothing. So then there's a hole. I know. Okay, so this graph looks like this. Now, this next one is very similar, but it's different. Okay, this is a little tricky. At 1, You gotta approximate the slope. I know it's not possible, but approximately what is the slope? What, like if you draw a tangent line, what would be that slope? Maybe 1 or a little bit smaller than 1 because it looks a little bit flatter than the previous one. At 2, is it higher slope or same slope or lower slope than at 1? Lower slope, right? If you draw a tangent line, at these 2 points, you can see that this one is a little bit higher than that one, right? So it's going to slowly decrease its slope. Yeah? So let's, we don't really know exact numbers because we're just approximating. Let's say the first one was 1 and then the second one's like maybe 1/2. When you're really close to 0, let's say 0.1. What is the slope? Is it higher or lower than before? Than at 1 or 2?
Higher.
Higher. And what's going to happen when you're really close to 0?
Really high.
Really high. And then almost like a vertical line, right? Because if you keep drawing this tangent line, it's going to almost look like a vertical line. So then this graph actually probably will go like that. And then the other side, well, is the other side a positive slope or negative slope? Negative slope, so it's going to go down. So probably something like this. Okay, so these 2 graphs, even though those 2 points are both not differentiable, it's going to look different. One is going to be a constant towards 0, and constant towards 0, therefore there are 2 holes. But this one, the slope is changing almost to a point where it's like vertical, so then it shoots up. Okay, let's look at 2 more graphs. Continuous or differentiable? Okay, gotta answer those 2. Okay, raise your hand if you can tell me, is this continuous? Someone raise your hand. Raymond? Is it continuous? Huh? Yeah. Okay. Is it differentiable at 0? Gary? Yes? Yes. No. No, it's not differentiable. Why not? Okay, so let's look at 0. What is the slope? Well, if I were to draw a tangent line at this point, at 0, if I were to draw a tangent line, how would it look like? Raise your hand. Yes? Yes. A vertical line. What is the slope of a vertical line? Someone? Peter? Undefined. Therefore, not differentiable. Okay, so you can't draw a line, but that line has a slope of undefined. Undefined means no slope. Okay, so we cannot draw a straight line through. So anything that has a tangent line that is a vertical line is basically saying no derivative. Okay, so no, because f prime of 0 is undefined. One more, and then I open up for questions. Please write them down for now. All right, last one. We have a jump graph. Raise your hand if you can tell me, is it continuous? Yes. No, definitely not. Therefore, is it differentiable? Raise your hand if you can tell me. No, you don't even have to check. If it's not continuous, it's not differentiable. But please be careful. They're asking for x at 0. It is differentiable other places because it's continuous other places. At 0, because it's discontinuous, therefore it's not differentiable. But everywhere else, it is differentiable and continuous. Okay? All right, questions? Yes?
So although like in the first one, although like they have the same slope, but it's a vertical line, so it's
The first one?
Yeah.
Yeah, right. Yes. Any other questions? Okay. Yeah.
So that's gonna be really confusing. Never mind.
Okay, so then some of you had this question. So is a parabola at 0, let's say this looks like that, is that differentiable? All right, let's think about it. At that point, the lowest point, which is like the absolute minimum, First of all, is it continuous, everybody?
Yes.
Yes. Second, is it differentiable? Can I draw a tangent line through it?
Yeah.
Yes, you can. Now, if you draw a tangent line, what would that look like? Straight line, right? Straight line. If you look at the tangent line from either side, you can see that it kind of all comes down to a flat point, and then on the other side it's the same. So then they're coming down to a flat line. And that means the derivative at that point is just 0. And this is very critical because we need this information for our next chapter. It's a thing that we have to remember. At minimum or maximum of something, it's always going to be 0 because you always create a flat line. Now, if you want to kind of hear the summary is that anytime you have a sharp corner, it is not differentiable. Any sharp corners is not possible to be differentiable. So if your function looks strangely like that, all the sharp corners are not differentiable. Yes.
So, parabola differentiable.
Yes. Yes.
Because you can draw it. Okay.
Yes. So smooth curves are always differentiable.
So like a sine graph.
Yes. And pointy graphs or corners or disconnected are not differentiable. All right. Let's make another exception. Sky.
I thought the derivative of x squared equals 2x.
That means that the function is like a 2x everywhere. But you have to plug in the actual numbers.
Oh.
Yeah. Yes.
Number 3 over square.
Yes.
Can you have like a derivative of x
At 1, yes. Because you can't draw a tangent line.
but it hits the rest of the line.
You mean it hits here?
Yeah.
Okay, so tangent line means that you're creating the slope using only one point. It doesn't mean that you cannot cross another point. It just means you didn't use 2 points to create that slope.
Okay.
Yeah. Okay, let's go on. Let's do this. Okay, find all points in the domain where it is not differentiable. Okay, so you can't try to do this with no calculator because you can't imagine the graph, right? So this is a absolute value graph, and then the question is where on this graph is it not differentiable? You guys already all know? Okay, Eleanor?
Oh, it's the absolute.
Yes, where is that?
Sorry.
Elizabeth?
2, 3.
Huh?
Okay, so
2, so close. Yes.
2, 3.
2, 3. Okay, so, but we only care about domain, so we just want to say 2. So, if you recall, this is the absolute value graph, right 2 up 3. And then we said all corner points or all pointy points are not differentiable, so it's not differentiable at 2. Okay, so they just want to care about the domain, so you just write the domain. All right. This next one's a little bit trickier. You have to think about this a little bit. X squared minus 9 absolute value. Well, let's think about x squared minus 9. How does x squared minus 9 look like? Yeah, parabola, and then what happens to the parabola? Down 9, right? Okay, so this is how the graph looks like. Now, when you put an absolute value on it, absolute value means make everything positive. Yes, so basically you're flipping the part that is negative up. So absolute value says take all the y values and then make them positive. So it's going to flip them up. Okay, so now think to yourself, which points are not differentiable? So I'm going to let you kind of do it for maybe 10 seconds. Write down those values. Which numbers in the domain of this is not differentiable? I know some of you already know, but some of you need to try it out. Which numbers are not differentiable? Okay, William.
3 and negative 3?
Yes, 3 and negative 3. All right, next. Is the function differentiable at x equals 2? Try it. What are you looking for? Okay, try it. Is the function differentiable at x equals 2? Remember, when it's asking you for differentiability, there are two questions you ask. Number one, is it continuous? Number two, is the derivative from the left and the right the same? Okay, so you got to answer those two questions. All right, so this is like the kind of question they were going to ask you on the test. Okay, first thing, is it continuous? That's the first question. Is it continuous? Okay, how do you check to see if it's continuous? Or how do you prove that it's continuous? Yes? Plugging it in, what are you looking for?
It's the same number.
Okay, so let's do this the actual way. So limit from the left-hand side has to equal the right-hand side. Okay, that only proves that there's a limit. If it does, then you check, is the limit actually equal to the number? Which it does. So they're both going to 5. So yes, it is continuous. The second thing is it differentiable? Meaning, what is the derivative from the left? What is the derivative from the right? Are they the same number? Okay, then this is a little bit harder because it's a little long. H goes to 0. We're doing the left-hand side, so 0 minus. Let's do the first function, so that's x plus h squared plus 1 minus x squared plus 1 all over h. And then you do the whole thing to figure out what is the derivative. In this case, it is 2x, which means the derivative from the left is 2x. Okay, so f prime of x is 2x. So then f prime of 2, which is the derivative we want, is 4. Now we check the right-hand side. Limit as h goes to 0 plus from the right-hand side. So then what is this? 4x minus 3. So that is 4x plus h minus 3 minus the function. And then you check. This one goes to just 4. So the slope is just 4 everywhere. So f prime of 2 is also 4. So then the question is it differentiable? Yes. Okay, first, it's continuous. It's connected. Second, the left-hand side slope at that point is 4. The right-hand side slope is 4. It doesn't really matter what the rest of the graph looks like, but at that point, they do connect. They have the same slope. It's differentiable.